take a look at this picture and answer my question. Fact or fiction? Do you think that this triangle can truly exist? Now, if you have your answer in mind, I would like to pose a question this way. Let's say that this is the map of a cross-country race, and I've watched some cross-country races. I'm not going to go into what sport is the most difficult, but I've seen a lot of puking at the finish line. So anyway, let's say that this is the start of the race right here, this point right here, and you need to finish right here. That's not an E, people. That's the finish line, F for finish. So which path are you going to take in order to go from the start to the finish in the shortest amount of time or distance? Well, if you add up the lengths here, if you're going to go from start to finish, this route, the 3 miles plus the 4 miles, if you go that path, then 3 plus 4 is going to take you 7 miles along those two paths. But hold on a minute, shouldn't the straight line be the shortest way to get there? Isn't the shortest distance between 2 points the straight line? So the 8 miles should be the shortest, but it isn't. If we add up these two, these are definitely shorter than going the 8 miles. So can a triangle like this really exist? The answer is no. If you said no, then you were right. This is definitely fiction. I can draw it and I can put numbers on there, but if I could really make it happen is another question. And that's due to the triangle inequality theorem. And what it says is that in a triangle, the length of any side has to be less than the sum of the lengths of the other two sides. So what's happening there is that if I took my 8 miles and my 3 miles and actually drew it to scale, it would look a little bit more like this. There's my 3 miles and my 4 miles. And the problem is they're not going to be able to connect up. Even if I were to bend that angle in a little bit and bend this in a little bit, are they going to connect up? They aren't. They're just going to lay flat there on that 8. There'll be an 8, there'll be a 3, and there'll be a 4 segment, and there's still going to be that gap of a 1 mile gap there. So those 3, 4, and 8 really cannot make a triangle. They have to fit this theorem. The length of any side has to be less than the sum of the lengths of the other two sides. So let's see if that's true with this. If I take 8 as my side and I look at the sum of the other two sides, the 3 and the 4, is it true that that is less than the 3 and the 4? Is 8 less than 7? No, it's not. So that doesn't work. So let me show you how this works as a test. So here's 3 numbers, and we want to know if they could make a triangle. This is the way you could figure it out. What I would do is take your biggest side, which in this case is the 29 feet, and check out the inequality. Does 29 compare to 14 plus 10? We're going to add those together. Is 29 less than 14 plus 10? That's the question. Well, let's add it up. 29 compared to 14 and 10 makes 24. That is not less than. In fact, that's a slash through that. So this is a no. That really wouldn't make a triangle. It would look like our last picture. I'd have my 29. I'd have a side of 10, and I'd have a side of 14, and I'd have a big gap where they're not meeting up. All right, next one. Again, I'm going to take my biggest side, which is the 11 here, and I want to compare 11 to the sum of the other two, to 7 and 6. Is that less than 7 plus 6? Is 11 less than what's totaling 13? That is a yes. So that would make a triangle. I could have a triangle with a side of 11, 7, and 6, and they would connect up. And then this last example here, we've got the 1, 2, and 3. So 3 is my biggest one. Does 3 come out less than 1 plus 2? This is a question I get a lot from students. Well, 3 is equal to 1 plus 2, but this is a strict inequality. It has to be less than. So since 3 is not less than 1 plus 2, that was a question, then I say no here. And this would be a situation where I would have my 3, I'd have my 1, and I'd have my 2, and they would connect up, but would they form a triangle when they connect up? No, they just form 2 flat segments right on top of the other. Now this last couple of examples is a different type of question that lets you practice the triangle inequality theorem. So in this one, they don't tell you all 3 sides. They only give you 2 sides, and you have to figure out what are the possible values of that third side. And it's not just going to be one number, it's going to be a whole range of values. So I'm going to call my third side x. I've got 13, 20, and x as the sides of a triangle. What are the possibilities for x? Here's my strategy. I'm going to first start out by assuming that x, or the missing side, is the biggest one. So if it's the biggest one, then that means that it has to be less than the 13 and the 20 combined. So I'm just going to add my two numbers together to get the biggest possible value for x. That's going to be 33. In my next assumption, I'm going to say, well, hold on a minute, maybe x isn't the biggest side. I don't know what it is, so how can I say it's the biggest? If it's not the biggest, then that means 20 is the biggest side. And so in that case, I would take 20 and say that's got to be less than 13 plus x, the two smaller sides together. Well, if I want to solve for x, I'm going to subtract that 13 off. In fact, I'm going to write that one down. So I'm going to take away 13. I'm going to subtract my two numbers. And I'm going to find that 7 is actually going to be smaller than x is, or x is bigger than 7. So x is bigger than 7, but over here x is less than 33. So it's really a range of values. Our missing side could be anything between 7 and 33. So I would write it like this. X is between 7 and 33. Or mathematically, the way I would say that is I would say 7 is less than x, which is less than 33, just like that. Put x between the two. So I'm saying that the missing side could be 10, it could be 19, it could be 22, anything as long as it's between 7 and 33. If I go bigger than 33, I'm too big. If I go less than 7, I'm too small to make a triangle. But look at the pattern that is here, and this is something you can use to quickly find the answers to these questions. What did I do with the 13 and 20 in my first part? 13 plus 20, they got added together. And what did I do when I found it when x wasn't the biggest? I subtracted them. So I can get my two boundary numbers by simply taking the givens and adding them, and taking the givens and subtracting them. That's how I got my 7 and my 33. So let's just try that with this next example. Okay, so what are my possible values of x? Well, first of all, I'm going to take my two numbers and add them together. And that'll give me my biggest possible value, 18. Then I'm going to take my two numbers and I'm going to subtract them. And that'll give me my smallest possible length of 2. So that means that x is between 18 and 2. Anything between 18 and 2 will work. And I can't spell between, so forgive me. X is between 18 and 2. Mathematically, if you want to write it that way, it's 2 is less than x, which is less than 18. And that's all you got to do. So do you try these, and we'll see how this works out for you tomorrow.